The fundamental theorem of calculus, part 1. We'll look at part 2 a bit later. Consider the area under the graph of y equals 3, so this line is y equals 3, from x equals 0 to x equals a, where a can belong to 1, 2, 3, 4 or 5, as we can see in the diagram. So if we take the a equal to 1, we can see that we get a 3 by 1 rectangle. So when x is 1, the area is 3. If a is 2, then we get a 3 by 2 rectangle which has an area of 6, and then we can quite readily see that 9, 12, 15, building up the table that we have here. The table suggests that we could suggest an area function for this graph, area of x being 3x. Note that if you integrate 3, you get 3x plus a constant. So we're now going to consider the area under the graph of y equals 2x. X equals 0 to x equals a with the same things here. So if we think about this area when x is 1, we're talking about a triangle with a height of 2 and a width of 1. Half times 1 times 2 is 1. If we now have this bit shaded, we've got a height of 4 and we've got a width of 2. A half times 2 times 4 is 4, so the area is 4. And so on. We get an area of 9, then 16, then 25. And I'd hope that you would spot those as the square numbers. And therefore, we could suggest an area function a to the x is x squared. A note from earlier work that the integral of 2x, the indefinite integral of 2x with respect to x, is x squared plus a constant, the same as our suggested area function, just if we ignore the constant. This leads us to the idea that the area under a line or a curve is linked to the integral of the function for that line or curve. This is indeed the case, and one of the fundamental theorem of calculus statements is that the integral from a to b of f of x dx is f of b, take away f of a, note this is a capital F, where the capital F is the antiderivative or indefinite integral of f of x. There's no c required for this. The integral from a to b of f of x dx is known as a definite integral, and we may have already met these. In fact, we did actually do it on the calculator a few times, but we're now going to look at definite integrals.